We've spent decades listening for alien voices, waiting for a clear, unmistakable signal from the stars. A greeting, a beacon, a cosmic hello, and we've heard nothing. Or so we think. What if the galaxy isn't quiet? What if it's full of activity, energy flowing, stars dimming, pulses flashing, and we've been mistaking it all for static? It is entirely possible we have already recorded the signal, a brief anomaly, a strange burst, something that didn't fit our models, and because it didn't look like a message, we filed it away as noise. SETI isn't just a search for aliens, it's a test of whether we would recognize intelligence at all. Why SETI is harder than it sounds. When most people imagine the search for extraterrestrial intelligence, they picture something very simple. Somewhere out there, an alien civilization builds a transmitter, points it at the stars, and starts broadcasting a message. We build a big radio dish, point it back, and one day we hear a signal saying, hello. That image is comforting, it's tidy, it suggests first contact will be obvious, unmistakable, and timely. But the real search for alien intelligence looks nothing like that. SETI is not a phone call, it's closer to archaeology, forensics, and pattern recognition conducted across light years and millennia. Any signal we detect will arrive long after it was sent, stripped of context, distorted by distance, and buried in cosmic noise. It may not even be meant for us. It might be accidental, automated, or the side effect of some industrial process. The nearest might not be 50 light years away, it might be 1,000. At that distance, even a civilization broadcasting like 1970s Earth would vanish in the background noise. That's the classic SETI picture most people imagine, but it's not the only approach, and it's no longer the primary one. In practice, SETI isn't about waiting for aliens to speak. It's about asking a much harder question. If intelligent life exists elsewhere, what traces would it leave behind? And would we recognize them if we saw them? Today we'll walk through how SETI began, why its earliest assumptions made sense, why those assumptions turned out to be incomplete, and how that search has evolved. This is a gateway episode, a map of the terrain, so we'll cover the foundations without assuming prior knowledge. We'll also explore ideas that often get left out of simpler explanations. Because the silence so far doesn't necessarily mean that no one is out there. It may just mean we were listening for the wrong things. The Birth of SETI, Radios, Optimism, and the Early Search. SETI, the search for extraterrestrial intelligence, emerged in the mid-20th century at the moment when radio technology was transforming human civilization. Radio waves could cross oceans, pass through clouds, and reach into space. For the first time, humanity could plausibly imagine communicating across interstellar distances. From that perspective, radio made perfect sense. It was cheap, well understood, and capable of traveling vast distances at the ultimate speed limit of the universe, the speed of light. If aliens existed, and if they were trying to communicate, radio seemed like the obvious choice. Early SETI projects reflected this logic. Astronomers began scanning nearby stars for narrowband radio signals so clean and precise they are extremely unlikely to be produced by natural astrophysical processes, which almost always emits across wide bands of frequencies. A typical FM radio station broadcasts somewhere between 88 and 108 MHz, and individual radio stations are much narrower, an order of about a thousandth the frequency, so very tight. By contrast, Jupiter is a very loud natural radio source, emitting intense radio noise across a broad range from roughly 3 to 40 MHz, and even lower into frequencies beneath the AM radio band. Much of that lower frequency emission never reaches the ground because Earth's atmosphere blocks it. Jupiter then is a wideband source, the radio equivalent of white light in optics, where many frequencies are blended together, like your light bulbs with the sun, rather than concentrated into a razor-thin line on the spectrum like a single color. Of course, the expectation was not that aliens would sound like voices or music, but they might broadcast simple, unmistakably artificial patterns, repeating pulses, prime numbers, or signals locked to a stable frequency. This approach wasn't naive, and it reflects a concept I say a lot in our discussion of SETI, aliens, and the Fermi paradox. Intelligence recognizes intelligence, and can guess what makes them easiest to spot by others. The approach was grounded in what humans themselves were doing at the time. Earth leaked radio waves into space through television broadcasts, radar systems, and military communications. A technologically young civilization just discovering radio would be naturally very loud. There was also a deeper assumption at work, one rarely stated outright. SETI assumed communication was cheap compared to travel. Building starships was hard, slow, and expensive. Sending signals was easy. So if alien civilizations existed but hadn't visited us, they might still talk to us. And critically, we already knew our telescopes would not detect casual radio chatter meant for use a few hundred miles away on a planet's surface. We couldn't hear their television programs. We couldn't overhear their radar. If we heard anything at all, it wouldn't be our technological twin idly broadcasting sitcoms. It would be intentional. A hello signal, a teaching beacon, a deliberate Rosetta Stone designed to introduce a new civilization to the galaxy, and broadcast orders of magnitude louder than everyday communication was. We were not listening for our twin, we were listening for a lighthouse. A place meant to be seen. That basic assumption shaped decades of search strategies. We listened for messages because we expected messages to exist, or at least be the easiest way to spot alien civilizations if they existed. Why Radio SETI made sense, and why it didn't work. As decades passed, SETI kept listening, and the universe remained stubbornly quiet, at least to the unambiguous real deal. Many were expecting something clear and obvious, even if not easy to translate. We had false starts like quasars that seemed suspicious, or the well-known WOW signal detected here in Ohio back in 1977, which we have a lot of theories on, but no real consensus on either. And while most, myself included, think it was probably natural, a lot of reasonable people do think it might be alien. I could do a whole episode on those theories, and maybe I should at some point, but for now, it's the lone exception, and the signal itself doesn't seem to contain any clear patterns either. No pulse repetition, modulation, or follow-up signals. Whatever it wasn't a lighthouse. This overall absence of detection is often portrayed as a failure, but it's better understood as a lesson. Radio SETI did not fail because the idea was foolish. It failed because it relied on assumptions that turned out to be incomplete. The first problem is leakage. Earth's radio emissions were loud in the early days, but they did not stay that way. As communication technology advanced, signals became more efficient, more compressed, and more directional. We stopped blasting powerful broadcasts in the sky and started sending tightly focused, low-power signals exactly where they were needed. A mature civilization does not stay radio bright forever. Loud is a phase. Efficiency is a destination. So it becomes quieter, though it might stay loud with something like GPS or time and date signals. Just because most communication is quiet does not mean deliberate beacons do not exist, or obnoxiously bright billboards telling you to shop at Tau SETI. The second problem is energy economics. Omnidirectional radio beacons waste enormous amounts of power. Even a civilization with access to stellar-scale energy resources still faces trade-offs. They could easily afford a signal heard galaxy-wide, but does not mean they're comfortably wasteful. The US has entire divisions of troops. We still don't send a battalion in to arrest somebody for a misdemeanor. Everyone has a budget, and probably someone who's looking for an excuse to trim it, or accuse the person in charge of it of being wasteful. Power spent shouting to the void is power not spent on computation, infrastructure, or expansion. And shouting indefinitely in all directions is the least efficient way to communicate imaginable. This is where a key insight emerges. Having vast energy does not mean wasting it. Advanced civilizations are likely to be efficient, not extravagant. Advanced does not mean reckless. The third problem is noise. The radio spectrum is crowded. Natural astrophysical sources produce radio emissions across a wide range of frequencies, like Jupiter. Civilizations, meanwhile, would quickly learn to encode and compress their communications, making them blend into background noise rather than stand out as simple, repeating patterns. In short, Radio SETI assumed that aliens would be loud, wasteful, and obvious, and that assumption does not survive contact with either economics, engineering, or observations. Silence in this context is not surprising. It is exactly what we should expect. The shift in perspective, from are they talking to what are they doing? As these limitations became clear, SETI began to evolve. Instead of just asking whether alien civilizations were broadcasting messages, researchers started asking a more fundamental question. What would advanced civilizations actually do, and what unavoidable traces would that activity leave behind? This marks a crucial shift. Communication is optional. industry is not. The whole point of intelligence and technology is that you alter the natural world to help you better survive or thrive in it, and this by definition must leave a footprint. A civilization might choose not to talk, it might be cautious, indifferent, or simply uninterested in announcing its presence, but any civilization that grows beyond its home planet must manipulate energy and matter on increasingly large scales. And those activities have physical consequences that cannot be perfectly hidden. This realization opens the door to new approaches, searching not for messages, but for technosignatures, detectable evidence of technology, as opposed to biosignatures, which are signs of any life, and might be a planet reflecting more green light than we expect. Before we get to the most famous example of technosignatures, though, there is an intermediate step, one that still involves communication, but in a very different form. Laser SETI, talking with flashlights instead of foghorns. If radio broadcasts are foghorns, loud, unfocused, and wasteful, then lasers are flashlights, narrow, precise, and efficient. Laser SETI is based on a simple idea. Instead of broadcasting weak signals in all directions, a civilization could send extremely brief, extremely intense pulses of light directly at specific stars. A single nanosecond laser pulse, properly focused, can briefly outshine an entire star when viewed from the right direction. More to the point, while a laser spreads over distance too, you can focus it down merely to the entire habitable zone of a star system, indeed a lot more, and basically target every star system in the galaxy with less energy but higher volume than an omnidirectional signal that would reach about 1/1,000,000th of those stars instead. Space is mostly empty, so why bother talking at it? So the key advantage here is efficiency. Laser signals concentrate energy into a tight beam, dramatically increasing detectability while reducing total power expenditure. They are also unmistakably artificial. Stars do not produce nanosecond optical pulses with precise timing and repetition. Laser communication also implies intent. You don't accidentally hit another star system with a tightly aimed laser. Doing so requires knowledge of orbital mechanics, proper motion, and stellar distances. It suggests the sender knows who they are talking to, or at least who they are trying to reach. This targeting ability allows for something radio struggles with: personalization. A laser signal could be timed to match a planet's day length or year. It could encode spatial information in a pixel grid. It could act less like a broadcast and more like knocking on a door. You might send a 1-second pulse to Earth that flickered 365 times over a handful of minutes, then did it again in 24 hours. That uses very little energy. That also makes it abundantly clear it's an artificial signal to us, but also loudly states that you can see this planet and it was the target, so they might as well reply rather than trying to hide. It's like knocking on the window of someone's dining room while they're all at the table and waving. It's too late to pretend nobody's home. People, or aliens, have an obvious reason to be a bit hesitant to reply to messages, and there's another advantage of this approach. Directed signals are discreet. A civilization using laser communication can contact specific targets without advertising itself to the entire galaxy. That may matter in a universe where caution is rational and attention is not always desirable. Laser SETI doesn't assume aliens are chatty. It assumes they choose to communicate, they would do so efficiently, deliberately, and quietly. And that assumption aligns far better with how advanced technology actually behaves. Dysonian SETI, listening for industry, not greetings. If Laser SETI asks how aliens might talk to us efficiently, Dysonian SETI asks a more unsettling question. Well, they never talk at all. Dysonian SETI is named after the physicist Freeman Dyson, who suggested advanced civilizations might surround their stars with vast structures to capture energy. The key insight wasn't the megastructure itself, but the logic behind it. Any civilization that continues to grow, whether in population, computation, or industry, will eventually face energy limits. And the most obvious large-scale energy source without new physics that is available to a planetary civilization is its own star. You don't need to build a solid shell around a star for this idea to work either. Even a loose swarm of satellites, habitats, or collectors intercepting a fraction of stellar output would fundamentally change how that star looks to distant observers. Energy captured must eventually be used, and energy used must eventually be dumped as waste heat. Thermodynamics does not negotiate. Stars do not flicker politely. If one looks dimmer than it should and hotter than it should, something is intercepting that energy. We have whole episodes dedicated to discussing how and why you'd build a Dyson shell, or rather Dyson swarm, without super advanced technology, if you want the details. But short form, It is hard the way building a highway is hard, not the way building a computer is. More technology helps, but it's basically brute force, not sophistication, that's required. We tend to assume growing civilizations inevitably build one in whole or part, and probably around any stars they colonize too. And this does not black the star out, it just changes the spectrum it emits. Earth absorbs visible sunlight and emits it as infrared wavelengths based on our planetary temperature. Energy cannot be destroyed, by any means we know of anyway, so anything absorbing is going to keep heating up until it emits an equal amount of power in other frequencies, or burns itself to ash. That makes waste heat one of the most reliable technosignatures imaginable. A star that looks dimmer in visible light but unusually bright in infrared may not be strange, it may be busy. A Dyson swarm does not have to be complete. Even 1% of a star's output is mega-civilization scale power. The power of Dysonian SETI is that it does not assume intent. A civilization might choose not to communicate, might be cautious, isolationist, extinct, or entirely post-biological. It might not even think of itself as a civilization anymore, it could be a single giant hive mind or AI, but if it's doing large-scale work, running simulations, manufacturing structures, moving mass, or maintaining habitats, it will leave fingerprints in the energy budget of its system. This reframes SETI in a profound way. Instead of listening for greetings, we begin scanning for infrastructure. Not hello, but activity. But there's also an uncomfortable implication here. Dysonian SETI may detect civilizations that are no longer conscious in a meaningful sense. Automated systems, self-maintaining industrial ecologies, or machine-run star systems could persist long after their creators are gone. In that case, SETI becomes less like eavesdropping and more like cosmic archaeology, discovering ruins that still glow with residual purpose. And unlike messages, ruins don't need to be aimed at us to be found. Signals, artifacts, and echoes. 3 very different targets. One reason SETI discussions become confused is that we often lump very different things together under the word signal. In reality, SETI searches for at least 3 distinct categories of evidence, each with different assumptions and risks. The first is signals, intentional attempts at communication, radio beacons, laser pulses, encoded messages. These presume a sender who wants to be noticed and believes someone is listening. These are the most dramatic form of contact and the most culturally loaded. Signals imply diplomacy, curiosity, or at least awareness of other minds. The second category is artifacts. These include megastructures, altered planetary atmospheres, stellar engineering, or objects placed deliberately in stable orbits. Artifacts don't need to transmit anything, simply exist. Their detectability depends on scale, longevity, and contrast with natural processes. An artifact might be abandoned, forgotten, or still in use, but its mere presence says something important. Someone was here. The third category is echoes. These are side effects of activity rather than its purpose. Communication leakage, waste heat, periodic energy modulation, industrial byproducts, things not meant to be seen but hard to hide. Echoes are especially valuable because they are the least filtered by intent. A civilization can choose not to speak and still be heard. Each category tells a different story. Echoes imply intent. Artifacts imply ambition. Echoes imply momentum. Fundamentally, a signal points to a mind reaching outward. An artifact points to engineering and long-term planning. An echo points to activity, but not necessarily awareness. Crucially, each category has different failure modes. We might miss signals because they are too brief, too targeted, or encoded in ways we don't recognize. We might miss artifacts because we don't know what artificial looks like at stellar scales. We might miss echoes because we mistake them for noise or natural phenomena. Understanding SETI means understanding which of these we are searching for and which assumptions we are smuggling in when we do them. Recognition is harder than detection. Even if alien intelligence leaves detectable traces, there is no guarantee we will recognize them for what they are. Detection is a technical problem. Recognition is a cognitive one. Modern astronomy already struggles with this. We routinely find objects that defy easy classification, stars that dim irregularly, galaxies with unusual spectra, fast radio bursts with puzzling repetition patterns. In most cases, the solution eventually turns out to be natural but unfamiliar, but that process can take years or decades and relies on building context through repeated observation. Alien technosignatures would face the same problem, only worse. By definition, they would be unprecedented. A signal might be recorded, cataloged, and archived without anyone realizing it was artificial. A laser pulse seen once and never again might be dismissed as an instrumental glitch. Infrared excess might be explained away as dust. Anomalies tend to be smoothed over by cautious scientists, not because they are closed-minded, because history teaches that nature is very good at surprising us. Also, it's sort of an inherent bias in science, which is the study of the natural universe. We tend to assume natural causes by default. There's also the problem of encoding. Even an intentional message may not look like a message. Mathematics is often assumed to be a universal language, but mathematics as humans practice it is deeply shaped by our biology, culture, and sensory experience. Patterns that seem obvious to one mind may be invisible to another. See our alien mathematics episode for more discussion on that. Compression also compounds the issue. Efficient communication removes redundancy, the very thing that helps us spot structure. The more advanced the signal, the more it resembles randomness. A perfectly compressed signal looks like noise unless you know how to decompress it. To an unprepared observer, the most advanced messages may be the least recognizable. Context matters even more. A repeating signal might mean attention. It might mean synchronization. It might mean nothing at all outside its original system. Without shared assumptions, decoding becomes a long, iterative process, not a eureka moment. Which means that patience, humility, and curiosity are not just virtues in SETI, they are survival traits for understanding a universe that may already be busy in ways we haven't learned to see yet. Today we're talking about how we search for alien civilizations and what we might actually notice first, but it's worth remembering we might overlook something strange simply because we don't recognize it as life. That's part of what makes gods and monsters so interesting. Curious Archive explores deep ocean creatures that already feel alien, ancient, massive, and often hard to classify. It's a useful reminder that alien doesn't always mean distant. Sometimes it just means unfamiliar. And if we ever face something unfamiliar close to home, my exclusive Surviving a New Ice Age explores how humanity adapts when conditions on Earth change in ways we are not prepared for. Indeed, you could get some giant behemoths underwater and on land again in a cold spell. If you enjoy exploring ideas like these, try out Nebula, where every episode of SFA appears early and ad-free, alongside years of monthly exclusives and content from hundreds of creators. Right now, Nebula is offering 40% off lifetime access, just $30 for permanent access to everything on the platform. Or you can use my link with the QR code to get 50% off an annual plan. That's just $30 for a whole year. What SETI looks like today. Modern SETI is no longer a single project or single technique. It is a layered strategy that overlaps with much of astronomy itself. I should note quickly that SETI is both the general name for looking for alien intelligence, and also shorthand for the SETI Institute, which is the best-known organization working on SETI, and I am generally using the broader term when saying SETI, not the organization. METI, or active SETI, incidentally, is the opposite approach, not listening but sending out contact messages. Radio searches still continue, but they are now broader and more agnostic, scanning wide swaths of the sky rather than a few favorite stars. Optical and infrared surveys look for brief laser pulses or unusual spectral features. Infrared telescopes search for excess heat that shouldn't be there. Planetary science hunts for atmospheric chemistry that suggests industry rather than biology, though we're looking for that too. It just isn't technically SETI, as biosignatures might indicate a planet covered in simple algae or lichen. Machine learning tools sift through massive datasets looking not for specific signals, but for anomalies that resist easy explanation. This is an important shift. SETI is no longer asking, has anyone called us? It's asking, is anything in this universe behaving in a way that does not make sense without intelligence? Modern SETI is mostly a more patient approach, not expecting a hello signal any moment now. And that's appropriate. Whatever civilizations exist out there are not synchronized with us. They may be older or younger by billions of years. Their technologies may be have ours or already gone. SETI is not a moment in time. It is an ongoing process, one that improves automatically as our instruments and models improve too. Every new telescope, every exoplanet survey, every better understanding of stellar behavior sharpens our ability to notice when something doesn't quite fit. It is also worth noting that SETI isn't something only professionals can participate in. Many modern SETI efforts rely on processing vast amounts of data, and some of that work is open to public participation. Citizen science projects let volunteers help analyze signals, classify anomalies, or contribute computing power to large surveys. You don't need a telescope in your backyard, just curiosity and a bit of patience. And while I've often said that I personally suspect there may be no one listening, and perhaps no one around to hear us in this whole galaxy, that's a conclusion reached from uncertainty, not certainty. And uncertainty is not emptiness. SETI is inexpensive, scientifically valuable, and deeply tied to how we understand intelligence and civilization. Even if it never finds anyone, it sharpens our view of the universe, and if I'm wrong, it may matter more than almost anything we ever do. SETI is a mirror, not a phone call. SETI is often framed as a search for others, but it's also a way of studying ourselves. Every assumption we make about alien civilizations, how long they last, how loudly they broadcast, how much energy they use, whether they choose to be visible, reflects an assumption about what intelligence becomes when it matures. When SETI finds nothing, that absence still tells us something. Not that the universe is necessarily empty, but that intelligence may be quiet, efficient, cautious, brief, or simply uninterested in announcing itself. The most important lesson SETI has taught us so far is humility. Intelligence does not guarantee visibility. Technology does not guarantee communication. And existence does not guarantee survival. That's a reminder that the universe is vast, old, and under no obligation to be obvious to us on our pale blue dot, and a quiet encouragement to build civilizations worth detecting, whether anyone else ever does or not.